Hello. So, in this video, we are going to learn about the limitations of dimensional analysis, and also we are going to find dimension of some of the complicated uh, physical quantities, and also take some complicated problems. Uh, First limitation, it doesn't give, dimensional analysis doesn't any information, numeric, logarithm, etc. So as we know, numerical values, they directly get eliminated, they are dimensionless, so we can't do anything. We give no information uh, about such type of coefficients by using dimensional analysis. Next, it gives no information about nature of physical quantity. So if we take dimension of speed, it is Lt minus 1. Dimension of velocity, it is still Lt minus 1. So it is not conveying anything. It is safe, and from find any information physical quantities. And also, like I had given an energy, its dimension is mL2t minus 2, and torque, its dimension is also mL2t minus 2, but their nature is different. So we looks like both can be we know they have different nature, but their dimension is not conveying that information. Vectors and vectors or scalars. So vectors or scalar, we have little bit information about vector and scalar, I guess. So dimensional analysis only deals with the involvement of fundamental quantities in that physical quantity and nothing more than that. So it gives information about vector quantity or scalar quantity. So now moving on, some of the complicated topics, complicated formulae, and we are going to find SI unit or dimension from those formulae. So first is, let's start with some simple formulae. So here we have coefficient of viscosity. It's eta. So the formula for this coefficient of viscosity is not direct. Actually, in the liquid there is a kind of force, and we call it viscous force, which is equal to A delta V by delta X. Actually, V by delta velocity gradient. But here we will consider it we will split it into two parts, velocity separately and delta x, this distance, separately. So in order to find dimension of eta, both sides, A is area, by the way, velocity delta x, a distance, so mlt minus 2, eta we have to find, area L2, change in velocity, that is Lt minus 1 divided by L. Alright, if we do some simplifications, eta dimension m L minus 1 T minus 1. Do little bit maths, you will find this result. That was coefficient of viscosity. There's for coefficient of viscosity with this formula also, 6 pi eta r. Eta again coefficient of viscosity, r radius of that object which is moving through the liquid, v is the velocity of that object moving. From this formula also you will find. Okay, next one, universal gravitational constant. Remember, small g is acceleration due to gravity. It is simply acceleration. So universal gravitational constant, we can find it by this formula, Newton's law of gravitation, or this formula, relation between acceleration due to gravity and gravitational constant. From here, g is fr square upon m1 m2, and if we dimension of f is mlt minus 2, L2 upon mm. You can find it. And here also, dimension of g is Lt minus 2, because it is acceleration ultimately. It is m. So finally you will end g equal to m minus 1 L3 t minus. Fine, try it and you will able to find this result, because most of time if you can memorize this, well and good, but if you can find it in few seconds, what is the problem? Next, gas constant. So we have ideal gas equation, PV equal to mu RT. Some I write, and in some books of high standard, they use symbol mu. P is mu number of moles. Moles means quantity of moles. It is not simply a number. It is not a numerical value only. It is associated with some unit, and that is mole. This is the gas constant. And T is temperature, absolute temperature. So I am in my lecture, I am introducing Dimension of V we have already of V dimension of R we have to find. This is Kelvin. Now we can easily find it. That will be M L2 T minus 2. See, we can simply calculate it. We can simply do some algebra and we can find it out. Divided by mole. So this is mL2 T minus 2 per mole per Kelvin. This is the dimension for R. Now 3 more or I can say 4 more capital C, which is equal to Q by T. Q is heat and T is temperature. So Q is heat. So it is mL2 T minus 2 and temperature. This is temperature. In order to avoid K, this is temperature. So dimension of C is mL2 T minus per Kelvin. And